Alright guys, back with some more applications. A guard tower is 140 feet off the ground. The angle of depression from the tower to an enemy force is 5 degrees. To the nearest foot, how far is the enemy force from the guard tower? So I've got this guard tower drawn here. Here's the ground, and there's the enemy. We assume this makes a 90 with the ground. So here goes. 140 feet off the ground, they gave us the angle of depression. Angle of depression is always measured from the horizontal. Always from the horizontal. So I am going to come in here. I am going to draw, if I can keep from moving my stuff off camera here, I am going to draw a red line. That has to be 5 degrees from the horizontal. If that's 5 degrees from the horizontal, this has to be 85 degrees because the horizontal and the vertical have to be 90 degrees apart. So now I have an angle inside my triangle. I'm going to label my triangle. This is my opposite. This is my adjacent. Tangent of theta equals opposite over adjacent. Theta, in this case, is 85 degrees. Opposite is my unknown over my adjacent. Solve this equation by multiplying by 140. And we're going to come in here with our calculator. We're going to say 140 tangent of 85 equals, and we get 1600, and that's going to be in feet because the other measurement was also in feet. Okay, so there's one application for your guard tower. Okay, so now we've got a trapezoid. It has a top that measures 12 feet 3 inches and a bottom that measures 20 feet 6 inches. Both sides are 14 feet long and have an angle of elevation of 67 degrees. So I've drawn our trapezoid here. I have converted 12 feet 3 inches to 12.25 feet. And I've converted 20 feet 6 inches to 20.5 feet. So I've got the top and the bottom dimensions. We've been asked for the area of this trapezoid. Now remember, the area of a trapezoid is 1/2 A plus B times H. Now in my case, A is going to be 12.25. B is going to be 20.5. But we don't know H. H is the height of this trapezoid, 90 degrees from the base. So what I'm going to do is I'm going to take this triangle here, I'm going to make this bigger. So I'm going to take this triangle, and here's what we have. My unknown, my height, is here. I know this is 14 feet, and I know this is 67 degrees. And I'm going to label my triangle. This is my hypotenuse. This is my angle. And I would like to find this side here, which is going to be opposite of my angle. So I need a function that has hypotenuse and opposite. That is going to be sine of theta equal to opposite over hypotenuse. Okay? Now plug in my numbers. Sine of 67 is equal to my unknown over 14. So to solve this, you're going to multiply both sides by 14. So you get 14 times sine of 67 degrees is equal to my unknown. I'm going to pull up my calculator here, and I'm going to say 14 sine of 67, and I get 12.89. I'm going to go with 12.89. Okay, so my unknown is 12.89. That is the height of my trapezoid, 12.89. So I take that information and I come back to my original problem, and the height is 12.89. So now what? Now I'm going to follow my order of operations. I am going to add these two, and then I'm going to multiply. So I say 12.25 plus 20.5, and then I'm going to say that number times that number, which is 32.75. So 1/2 times 32.75 times 12.89. So 1/2 times that number times 12.89. And the area of my trapezoid is 211.07. And there's more, but nobody cares. And they said to round this to the nearest square foot, so we're going to say our area is 211 square feet. Okay, so you can use right triangle trig even for things like trapezoids if you use your imagination, draw it correctly, and label it. So there is applications for right triangles, and feel free to rewatch this video if you need to, guys. I hope this helps.